I've got 3 problems up on the board here, and it looks like each of them is a composition of inverse functions. And I know when I compose inverse functions, one function does something, the other undoes it, and I just get my original input back. So if I'm not careful, I'm going to make a mistake. I'm going to pretend to not be careful, and I'm going to make a mistake. So I'm going to say sine of arcsine is 0.7. Arcsine of negative pi over 13 is negative pi over 13. And arcsine of sine of 2 pi is 2 pi. I made a mistake. Okay. I want you to take a moment and see if you can figure out where that mistake is. I will give you a hint. Arcsine is not the inverse of sine. It's the inverse of a related function. Okay. So I will tell you I got 2 out of the 3 right. One of them's wrong. Pause the video if you need to. See if you can figure out which one I got wrong, and then we'll talk about it. All right, the problem is that arcsine is not the inverse of sine. It's the inverse of sine with a restricted domain. But we don't have a different name for that function. So in each of these problems, I need to take a look at the sine part and see, is that the regular sine function, or is this the part with the restricted domain that arcsine is the inverse of? So I need to take a look at what angle am I plugging in. I know that when I restricted the domain, I needed to have angles that were in the interval from negative pi over 2 to positive pi over 2. So what am I plugging into sine here? Well, I'm plugging in the value of arcsine of 0.7. Now, I don't know off the top of my head what that is, but I know that arcsine will only spit out angles in that interval. So that's fine. Here, what I'm plugging into sine is an angle in this interval, so I can view that sine as the sine with the restricted domain. So we're good to go there. Okay, so here I am composing inverse functions. They undo each other. I get 0.7. If I look here, what am I plugging into sine? Negative pi over 13. That's going to be in this interval because that's a negative acute angle. I can see the absolute value of this because 13 is way bigger than 2. The absolute value is smaller than pi over 2. So this would just be a negative acute angle in quadrant 4. So here I am working with sine on that restricted domain. And so arcsine can give me that. Here, what am I plugging into sine? 2 pi. That's not in this interval. That's not part of the sine function with the restricted domain. Arcsine cannot give me a value of 2 pi. That's not in the range of arcsine. So if the angle I'm plugging into sine, and this will apply for our other trig functions as well, if the angle that I'm plugging in is not in the range of the inverse trig function, which corresponds with the restricted domain of the trig function, then I'm not composing inverse functions. And then I would have to do this one piece at a time. So this one was wrong. Let's go ahead and do it the right way. Arcsine of sine 2 pi. Well, I know what sine of 2 pi is. That's 0. So this would be arcsine of 0. Now I need to evaluate the inverse trig. So I'm going to do my usual trick of giving it a name that makes me think angle. Okay. And then I can say this means that sine of theta has to equal 0 and theta has to be in this interval from negative pi over 2 to positive pi over 2. Now, that's going to correspond to basically, negative pi over 2, to basically the right half of the unit circle. And let's see, this point would be 0, negative 1. Here's 1, 0. Here's 0, 1. The only quadrantal angle in this interval that has a sine of 0, meaning the capital Y value where we intersect the unit circle is 0, would be 0. Okay, so this is the angle 0. Notice it has the same sign as 2 pi does, but it's in the appropriate interval. So I need to be careful when I'm composing inverse trig functions. If I'm looking at sine of arcsine of x, that will equal x whenever it's defined. Okay, so if defined, and in order to be defined, of course, that means that x is in the domain of arcsine, which would be from -1 to 1. Okay, but if I'm looking at arcsine of sine of x, that's going to be defined for any angle x. It's always defined, but it only equals x only if this sine is actually that sine with the restricted domain. So if and only if x is in the interval from -π/2 to +π/2. And the same thing's going to be true with the inverse trig functions. If you do the inverse trig function first, as long as it's defined, as long as you're plugging in something that's in its domain, then this is guaranteed to spit out an angle that's in the range of the inverse trig function, which is the restricted domain for the trig function. So this composition with the trig function on the outside will be a composition of inverse functions. But if you're doing the trig function first, you can plug in any angle in the domain of the trig function. And the domain of the trig function is much, much bigger than the domain of the trig function with the restricted domain. And so if this angle is not in the restricted domain of the trig function, which is the same as the range of the inverse trig function, then you would have to do this composition one step at a time. Evaluate the trig function, then evaluate the inverse trig function. All right, so let me just put a couple of problems up on the board for you folks to try. Some of them, you're going to have the nice shortcut that you're composing inverse functions, but do pay attention to whether the angle is in the appropriate interval or not. Okay, so let's try cosine of arc cosine of -5/8. Okay, and let's try arc cosine of cosine of -π/4. And let's try tangent of arctangent of 18. And let's try arctangent of tangent of 3π/4. Okay, 4 problems for you to try. Pause the video, try and work those out, and then we'll tune back in and we'll go over those together. All right, I'm going to start with the nice ones where it is a composition of inverse functions. Remember, if I'm doing the inverse trig function first, that's going to guarantee that the angle that I get out is in the appropriate interval. So as long as it's defined, then we're composing inverse functions and they're going to undo each other. So can I plug in -5/8 to arc cosine? Yeah, that's between -1 and 1. That's in the domain. So this is just -5/8. And I can plug in any value I want into arctan because that domain matches the range of tangent, which is all real numbers. So this is just 18. So those two were the simple ones. When I'm doing the inverse trig function last, so that the answer is going to be an angle, I need to make sure I'm only getting angles in the appropriate interval. So I'm going to just remind myself the range of arc cosine, that was from 0 to pi. Remember, that one corresponded to quadrants 1 and 2. And the range of arc tan, that was -π/2 to π/2. It was almost the same as arc sine, except that we don't include those endpoints. That corresponded to quadrants 1 and 4. Okay, so if I look here, what I'm plugging into cosine, that's a negative angle. That is not in that interval. So this is not cosine with that restricted domain. So this is not a composition of inverse functions. I have to do this one piece at a time. So what is cosine of negative pi over 4? Well, let's work it out. Notice we're in quadrant 4. So since we're in quadrant 4, cosine is a positive number. Okay. And then my reference angle is just pi over 4. That's 45 degrees. And if I look at my 45, 45, 90 triangle, I can see that cosine is 1 over root 2. And I've rationalized that often enough that I know that that simplifies to root 2 over 2. So this becomes arc cosine of root 2 over 2. Once it's time to evaluate the arc cosine part, I like to give it a name that makes me think angle. That way I have an equation that I can rewrite using the trig function. So this is telling me that cosine of theta is root 2 over 2, and theta is in the interval from 0 to pi. So this angle satisfies the first condition, but not the second. Now, the interval from 0 to pi corresponds to quadrants 1 and 2. That's a positive number. That's going to put us in quadrant 1. So we're just looking for an acute angle here. And then I look at the absolute value, root 2 over 2. What acute angle has that cosine? Well, that was the reference angle that we just had. So this would be a positive pi over 4. Okay. So because this wasn't in the range of arc cosine, I had to do that one step at a time. I had to first do the cosine and then the arc cosine. That's not to say that anytime the inverse trig function is on the outside, you have to do it one step at a time. If I were looking at arc cosine of 7 pi over 8, 7 pi over 8 is in that interval. So I could view this as cosine applied on that restricted domain. This would just be 7 pi over 8. And it's important that I know that because I don't know off the top of my head what cosine of 7 pi over 8 is. Okay. But I can evaluate this whole thing by using the fact that it's a composition of inverse functions. All right, so let's take a look at this one. Okay, arctan of tangent of 3 pi over 4. So I need to look here and say, is that in that range of arctan, which would be the restricted domain for tangent? No. I need to be between negative pi over 2 and pi over 2. That's an obtuse angle. So I've got to do this one piece at a time. So tangent of 3 pi over 4, let's go through our two-step process. 3 pi over 4 would put me in quadrant 2. In quadrant 2, tangent is negative. If this is 3 pi over 4, my reference angle is pi over 4. Back to the 45, 45, 90. Tangent of my reference angle is 1. So we're looking at arctan of negative 1. Okay. And so I'm going to call that theta, and I'm going to say this means that tangent of theta is negative 1. Now 3 pi over 4 satisfies that, but it doesn't satisfy the second condition. And theta is in the interval from negative pi over 2 to positive pi over 2. Okay. Now that corresponds to quadrants 1 and 4. That's negative. In these two quadrants, the one that tangent's negative in is quadrant 4. So my theta is going to be a negative acute angle. The reference angle, well, we've seen the angle, if I write that as alpha, I know that tangent of alpha is the absolute value of negative 1, which is 1, and that tells me that alpha is pi over 4. Again, 45, 45, 90 triangle, which I've had up on the board a couple of times here. Okay, so that's going to tell me that theta is the opposite of pi over 4. Excellent. Good stuff. Okay. I should just mention, I meant to say this at the beginning of this video, and I was so excited about doing the problems that I forgot to. We can define inverse trig functions for all 6 of the trig functions, and we will be doing that before we're done with this section. So we will define arcsecant, arccosecant, and arccotangent. But the 3 that we've defined so far are the ones that we work with the most often. So we're going to spend a little bit more time just playing around with them, and then return to just defining those other 3 and working with those definitions as well.